Hey, this is the next page. We're talking about permutations. And I want to just, in answering question 4, come up with a formula. Analyze the ratios of factorials you wrote in questions 1 through 3, and let R be the number of letters in a permutation. Let N be the number of letters to choose from. So N is the total, and R is the, what would you say, like limited amount of choices. So I'll say limiting amount or limiting number. Of the total, we want to make arrangements of 4, right? So write a formula to describe the number of permutations P of R letters chosen from N letters. Well, if I look at question 1, and I do have that right here, we wanted 2-letter strings chosen from the first 4 letters of the alphabet, and this was our permutation, 4 factorial, because we had 4 letters to choose from. And then the 2-letter strings, this 2 is not the 2-letter string. There's a subtle difference. So maybe let me choose question 2. In question 2, it's a 5-letter choice. We have 5 total letters to choose from that we're going to pick from and arrange into 3-letter strings. Now the arrangement matters. So ABC is different than CBA. Yeah, the order matters with permutations. Look at how the bottom of this factorial ratio isn't the 3. It's 5 minus 3. So there's this idea of in the parentheses, like in the denominator here, if there's a 4-letter string you can choose from the first 10 letters, finishing my sentence, the bottom of the fraction should be the result of what's left. Right? We have 10 letters of the alphabet, so I could write 10, 9, 8, and 7. But to write this into a ratio of factorials, which will actually help us with the formula for permutations, I need 6, 5, 4, 3, 2, and 1 to make this become 10 factorial. But if I'm going to add 6, 5, 4, 3, 2, 1 to the end of the 10 string, then I have to also divide by 6, 5, 4, 3, 2, 1 on the bottom, which is 6 factorial. And the only way we would have really gotten 6 factorial is if we had done 10 minus that number. So that 4 is visible in the fraction as 10 take away 4 factorial. And so the 10 on top is because we have 10 letters to choose from. But the 4 of the 4-letter string is not the denominator. It's 10 minus 4. And that number becomes the denominator because the denominator is what we had to add. You see that? We had to add a 6, 5, 4, 3, 2, 1 so that the first 4 and then these last 6 give us all 10 characters, but we're getting rid of 6 factorial of them, so there's a canceling. This is the formula. In fact, I'm going to pop that in over here. We have N things to choose from, and because of our desire to have R letters in an arrangement, the denominator of the permutation formula is N minus R, factorial. So like once we know how that's defined, we can just pop this in. In fact, here it is in question 5. Calculate each permutation using the formula N factorial over N minus R. Oh, there it is. Hey-o, reading ahead helps sometimes. Reading ahead gives you the formula. Okay, so our formula is N factorial over N minus R factorial. In fact, do you see how that formula is related to what we did in the previous 3 pages? Previous 3 questions on the last page? Well, let's get into this one then. Let's use the formula. So 6 is the total number of choices that we have, and we want to put those 6 things into an arrangement of 3 things. So how many different ways can we take 6 things and arrange them so that 3 of them form a group, form a permutation? So formula says N factorial, put a 6 there. Formula says N minus R, parentheses, factorial, so we go 6 minus 3, factorial. But that turns into 6, 5, 4, 3, 2, 1. That's 6 factorial, 6, 5, 4, 3, 2, 1. And on the bottom is 3 factorial, so 3, 2, 1. This 3 factorial and that one reduce to 1. They cancel out. Therefore, we have 6 times 5 times 4, which I know is 120. Oh, by the way, 5 factorial is also 120. Just for consideration's sake. Not to say that this is the equivalence, but anytime we see a factorial number pop up, like 6 and 24 and 120 and 720, that should at least trigger a mathematical connection to our list of factorials. Let's talk part B. So in part B, I'm going to do one more. Then I'm going to say you should practice the last question, with the setup and then see what you get. 10 things permuted one letter at a time. That would be 10 factorial, or 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 10 minus 1. Because the formula says this number subtracted by that number. So 10 minus 1, that's the n minus r in the formula. 10 minus 1, that's 9. So 9, 8, 7, 6, 5, 4, 3, 2, 1. The 9s cancel, reduce, 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 reduce. I don't know why I wrote it all the way out. I just did. But that makes sense in that if you have 10 things and you're going to make a group of one of them, there's one of them. I won't show you the second one. You know why. The thing is, of choosing just one out of 10 things, there's 10 ways to do that. As soon as we pick, 2 things, then we start running into, all right, there's more. There's like 90 different ways to do that. However, this is the way the formula is also confirmed to work. Now, I wrote right over the take note, and I'm sorry, so I got to talk about it. If you have these, yellow calculators here, and screen maybe is working well, there is actually a permutation button on them. And I want to see how this video works. I'm going to show you, can I show you from my screen here? Let's open this one up. I'm going to open up my calculator for you. So there is a permutation button that we can use, and this sequence, no thanks, sorry that you're seeing this right now, will let us do the permutation. Oh my gosh, I should have done this all off camera. Will let us do the notation, all of this, huh? Okay, first time apparently. Clear the scratch pad, clear it, done, visual. I want to go to visual. I'm so sorry, you guys. I should have had this all ready to go. View, tool, transfer tool, screen capture. I'm going to do this in the next video. I'm going to show you here, and then I'm sorry for wasting your time. Okay, so hope you can skip forward, and then we can get past this part. And I'll show you on the next window, oh my gosh, having such technical difficulties, how we can use the calculator to confirm that this is the answer for 6 factorial divided by 6 minus 3 factorial. You press menu. And when you press menu, right here it says probability. So that's option 5. Then we have this thing called permutations. There is factorial, by the way, but it just means I'm going to put an exclamation mark. I'm going to choose permutation, option 2. NPR looks just like our 6P3 or our NPR formula. So if I want to do 6 things, 3 ways, whoa, there it is. Sorry, it's blurry. 120 is the answer. Let's go to the next question. 5 permute 2 means 5 take away 2 factorial is the bottom. And I can just go right into this one, menu, 5, 2. And I can go 5, 2, enter. There are 20 ways to take 5 things and arrange them with 2 of them at a time. How did you calculate? Let's try the next one. A Sunday shop sells yogurt sundaes with 2 layers, 4 layers, or 5 layers of yogurt flavors. And the shop carries 65 flavors in all. N equals 65. So how many different 4-layer sundaes could you create without repeating flavors? Wait, what makes this a permutation? Because we say without repeating. If you're not allowed to repeat the flavors, then once a flavor is used, it's gone, and the total number of flavors left is 1 less. So anytime we go with a choice and you're taking away one of the options after a choice has been made, we have a dependent situation, and the arrangement will matter. So R, given us 4 layers, and they're all different, no repeating, we have a permutation. 65 permute 4. That looks like this. 65 factorial over 65 take away 4 factorial, which means 65 over 61 factorial. So 65, 64, 63, and 62. Because the 61 factorial divided by 61 factorials reduce. That's like the rest of them. This might be a little tricky on that one. I hope that you're seeing it. Ask me for more detail directly, and I'll certainly try to fill you in. I don't want to do that calculation. I guess I could do 65 times 64. Let's try that part. So 65 times 64 times 63 times 62. I got an answer of 16,248,960. Again, sorry, it's blurry. But if I do menu 5-2, I'm going to bring up my NPR, and I can go 65, 4, and now I get the same number because it is the actual answer. That's how it's calculated. But I can maybe think about this a little bit differently than just multiplying out all the way down. So our answer, 16,248,960, is the total number of ways that you could choose 4 flavors and have unique choices out of all 65 combos. Okay. So then what type of sundae would give you the greatest number of choices if you did not repeat flavors? Did not repeat makes this a permutation. The values of N is 65, and then in this problem, the 2 layers is R. So let's try this. In fact, how many more 5-layer choices are there than 2-layer? Or are there more 2-layer than 5-layer? Let's do the calculator to figure it out. I already have 4, so I'm going to write that one down. 4 is 16,248,960. 65, choose 2, menu 5-2. 65, permute 2 is 4160. Oh, that's not very much at all compared to the other. It's still a lot of different choices, but 16 million versus 4,000. Menu 5-2 brings up the permutation. Sorry for the glare. Brings up permutation, so I'm going to go 65, choose 5. Permute 5. And I have 991,186,560. Holy cow. By adding that extra layer, you're adding, I should subtract this. So I'm going to go this number subtracted by, you can press the up arrow button and then press enter, and it brings an answer down into the calculation. Wow, 974,937,000 more options by just adding that 5th layer. Formula. The formula for permutations is this one right here. Thank you for watching, commenting, liking, and subscribing, and I'll see you in the next episode.